and I'm going to talk about the DBIx Perlish module, going deeper into how it is implemented in our previous class. In particular, do you hear me? Do you hear me? Okay. Good. In particular, I'm going to be talking about three things. Basically, what DBIx Perlish module is, and it is a domain-specific language which looks just like Perl for doing database access. Then how actually it is implemented using tree parsing. And then since it turned out that it's just a tiny little bit on the slow side, and the last part of the talk will be about how to optimize the slow side of the transpose. Right. So we all know about Perl, right? And we all use DBI for our database access. But that requires using SQL. And, well, SQL is not a particularly nice language. It looks very different. It sort of disrupts the flow of the program when you have the Perl code and then pieces of SQL inside. And there are several different solutions to this. Of course, use some sort of object-relational mapper, DBIx plus, or whatever. But this module basically replaces SQL with Perl, or rather with a declarative language for database access, which looks just like Perl, but isn't. Basically, it looks something like that. So we have our Perl field here, and then we call a fetch from the database. And this thing is inside here. We basically say that we are going to be working with a table users, and we are going to be matching the main column in that table with the whatever is in the whatever is in the variable out here. And then we are going to be returning two columns, the ID and the password. And this is a real code. This is basically just going to work if you use if you perform your DBI database connection a little bit above there. This is a real code. It's not a pseudocode or anything. So and it does the right thing. And of course under the hood, because it's not implemented by any sort of database engine, this Perl-like declarative matching language. Under the hood, it will convert whatever is inside this query sub and convert it into the real SQL, which will get executed afterwards, and the data will get parsed and returned back to it. So, what's going on? First of all, of course, DBFetch uses this syntax extension possibility in Perl by employing prototypes with a sub. And if you have this sort of prototype, then of course you could skip the sub keyword and just use the braces. So in reality, it is the anonymous sub which gets transferred, which gets passed as a parameter inside the fetch, right? And of course we all used this sort of construction in our code many times. But typically, when we get a subroutine as a parameter inside another subroutine, we have two options. We can execute that sub or not. So here is a trivial example of executing the subroutine just passes the parameter. And here's a slightly more complicated example when they actually instruct the something subroutine whether we want to execute it or not. But the question is, what else can we do with this sub? Of course, we could pass it to yet another part or whatever. But we can also parse it because the past subroutine is basically an internal Perl object which has all the operations coded into it. And basically, we have a way of finding quite a lot about what the sub does and how it looks and all the internal stuff. And one way to do it, at least for the visual inspection when you're developing stuff and so on, is to use a wonderful concise module, which could walk the op tree for us and show us how it looks. So, and here I will be more or less interchangeably using two different ways of coding it. One, which is be concise as such, and another one which used to be a different module called be terse, but I think it's obsolete now, and basically be concise could produce a different sort of output if you supply the terse parameter. So, and if we call this op-tree walker with a very, very simple sub which takes a single parameter and then returns that parameter multiplied by 2, then instead of executing it, we'll get the op-tree. It might look scary, but it isn't. Not really. Basically, this is more or less precisely what Perl would be doing. It would be working this horrible looking data structure when it actually executes. Right? So in the beginning we have basically the subroutine entry point or exit point or whatever. Then we have a sequence of statements, and then we have the statement which is basically doing precisely nothing, just storing the underscore file and underscore line in it. And the next operator is a binary operator. It's an assignment. It has the left part and the right part. So the right-hand side of the assignment is a shift of an array with the name underscore. And the left-hand side of the assignment is basically a my parameter. Pod SD basically tells you it's the my parameter. And then we have the next, basically the semicolon. And then we have the return operator, which is a list operator, so we can return more than one thing. But in this particular case, it just returns a single thing, which is a result of a multiplication of that my variable, which we had at the beginning, with a constant, with a value of 2. So, pretty simple. The terse output looks somewhat differently. It provides you less information. But for our purposes, further down in the talk, it is probably a preferable way of doing it because you would immediately see, with a concise output, when you try to figure out what's going on, you have to basically see, oh, okay, one means this operation is having a single argument, and 2 means this operation is having 2 arguments, and the add means this is a list operation. And that's a little bit involved. So for what we are going to be doing, it is a little bit more useful to basically use those operations as names. I would like to point out that we are talking about precisely the same tree, precisely the same code, just presented differently. And we could see that this is a unary op, and this is a list op, and this is its code which does nothing, and so on. Alright. So, once we decide to use Perl itself as a domain-specific language, and we can parse Perl code within our program, we can basically assign entirely arbitrary meaning to the field. It should no longer be Perl or whatever, right? Because if you want a database access, then declarative language is useful, and Perl is not a declarative language. But it's entirely up to us. We are parsing some tree. So we decide what all those constructs which look like Perl actually mean. And after the parsing is done, we could actually do the execution of the meaning we want, not the meaning which Perl interpreter provides to us. For example, going back to the DBIx Perlish, again, we can say that a my variable with an attribute is basically an indication of a table name, right? And any sort of a statement will be a part of the where clause down the line. So here we just have a comparison which would normally produce a warning in Perl, right? It doesn't make sense. It will be like useless use of comparison operator in void context warning. But for us it makes perfect sense because we're going to mention stuff from statements, so we are just doing database. So, and again, we don't even have to stick strictly to the Perl syntax. We could invent our own number procedure. We could, for example, the DBIx Perlish has a construct, a backwards arrow thing, which does not exist in Perl. But that's not a problem, because the less than is a valid binary operator, and the unary minus or negation is a valid unary operator. So if we can parse it, if we can detect it, then we can just say, okay, it is a left. No problem.
You're a bad man.
So we could interpolate method calls within a string. And again, that is something which works using very sounds. Because that's how we address the columns. It's not a hash element, right? It's basically we hijack the method call syntax to address the columns in the database. And of course, it makes sense to interpolate method calls within a string. So that's what we get. The output in most databases, and that's what we get output in MySQL. I think Matt was talking about this. Right. So what else can we do? We could override the meaning we overridden and get back to Perl temporarily and do some conditional SQL generation within the queries. So in this particular case, we are still dealing with the table users, right? But this comparison, this part of the where clause, will only enter SQL if the value of $con variable is true at the moment, as if we were executing the program. So by running that, we'll be basically executing those two skills. Now, it all sounds very different, right? So is a Perl 5 porter required to write such a code? And the answer is no. And one case.